All right, I got a couple of guest speakers. Guest speaker number 1.
Negative power of a quotient property.
Guest speaker number 2, please.
A quotient raised to a negative power equals the reciprocal of the quotient raised to the opposite positive power.
Thank you, guest speakers. You're awesome. All right, so let's actually understand what these guest speakers are talking about. A quotient, so that's the answer to a division problem, raised to a negative power. So we're looking at, in this case, -3 equals the reciprocal, that's that fraction flipped. So I'm going to write flipped of the quotient, that answer to a division problem, raised to the opposite positive power. So that -3, if we were to guess based off of this, it's going to become a +3. So let's see how that can happen. We're using that whole last video. If you look at the video number 3 of the 4, you'll be able to understand what's going on a little bit more. But essentially what we can say is this 2/3 raised to the -3rd power, we can rewrite that as saying 3/2. So we just flipped it to the +3 power. So let's see what happened. We have that -3 turned to a +3, and this fraction, instead of being 2/3, is now 3/2. So that's the whole concept with this concept. So we can finish this problem and go one step further and say now we are going to distribute this exponent. So the exponents are on steroids for this whole problem. So we have 3 to the 3rd power over 2 to the 3rd power. And of course we can simplify that. 3 to the 3rd power is 27 and 2 to the 3rd power is 8. Next problem, let's try a couple of problems here. We have 4/3 squared raised to the 3rd power. So according to this negative quotient property, we can flip this whole idea. So we're going to flip it and have the 3 squared on top and the 4 on the bottom. And if we've done that, our exponent also needs to change and it'll become a +3. After that, we're just using that distributive property for all the exponents. So we have 3 squared times 3, after that exponent is distributed in, over 4 to the 1st times 3. So that's what that equals. So let's finish this math up. So we have 3 to the 6th power over 4 to the 3rd power. And of course we can simplify that further, whatever 3 to the 6th is, over 4 to the 3rd. And put that in a calculator, but that's how we do that problem. Next one. We have a little bit more action happening this time. We have s/3 raised to the -2nd power and 9s squared divided by t raised to the -1st power. So let's do this math. We can flip the first fraction to become 3/s, and we have a new exponent of a +2, so that exponent has changed. And now we can flip this other fraction, t over 9s squared, and we have the same thing happening with the other exponent, so that -1 has become a +1. That +1, that means essentially we do not have to worry about these parentheses anymore. We essentially just have straight multiplication across, but we need to worry about this exponent over here with this 3 and the 3/s. So we have now 3 squared over s squared, and our other equation that we're multiplying by is t over 9s squared. So let's combine like terms. We have s squared and s squared, so that becomes s to the 4th. S to the 4th. We still have our 9 that's right here, so we're going to have that there. And we have 3 squared times t. So there is our final answer for that problem. Last problem to practice this concept with, practice this flipping and distributive property with the exponents. So let's flip this fraction. We see 2a on top over b squared times c to the 3rd. So we're going to flip that into b squared c to the third over 2a. That's all been flipped. Awesome. And then we have a positive 4 as our exponent now. It's no longer negative. Distributive property to every single one of those base numbers. And so now we have b squared times 4, and then c cubed times 4 over 2 to the first power times 4, and a to the first power times 4. Let's figure out all those exponents, and then we are finished with this problem. So let's move this up a little bit. We have b to the 8th power times c to the 12th power over 2 to the 4th power and a to the 4th power. Final answer. Mainly final answer because there's no a's that are on the top or anything like that. There's no b's that are on the bottom. There's no c's that are on the bottom. So there's no other simplification we can do. And then 2 to the 4th we can actually multiply out, and we get, let me think, 2 times 2 equals 4. And then 2 times 2 equals 4, so we get 16 for that 2 to the 4th power. Anyways, thank you so much for listening. And please say goodbye to our guest speakers.
Bye, kids.
Bye.